At first I thought 3i Atlas was just another interstellar object, a quiet visitor passing through our system, nothing more. But the moment I opened the first raw data file, something in the numbers felt wrong. Not dramatic, not obvious, just wrong in a way that stayed with me. The object was first logged on July 1, 2025 by the Atlas Survey Network in Hawaii, a faint, fast-moving point of light. Standard orbital modeling showed it arriving from outside the solar system on a hyperbolic trajectory, the third such visitor ever recorded. Everything about it on paper looked ordinary, yet the light curve didn't match any typical comet profile. It brightened too slowly, then stabilized too precisely, as if some internal mechanism was compensating for solar heating. When I pulled up the early spectroscopic readings, the first anomaly appeared. The surface behaved like carbon-rich rock, dark, matte, absorbing nearly all incoming light. But the albedo spikes at narrow ultraviolet wavelengths didn't belong there. They hinted at patches of extraordinarily smooth surfaces, so smooth they bordered on engineered. No natural comet I've studied has ever shown that kind of precision reflectivity. Several colleagues suggested it could be an observational artifact. Others, speaking off record, admitted the pattern looked too clean. What concerned me most wasn't any single irregularity, but their consistency. Every dataset, from Atlas to Pan-STARRS, carried the same quiet signature of order hidden beneath randomness. Most people dismissed it as coincidence, but coincidences rarely repeat across multiple instruments. The first truly unsettling moment came when the Mars Reconnaissance Orbiter captured a high-resolution sequence during a rare geometric alignment. I was one of the analysts who received the raw frame dumps. When I sharpened the composite, I froze. The silhouette didn't look natural. It showed three elongated structures extending from the core at what appeared to be near-perfect 120-degree intervals. Faint, but unmistakably symmetric. I tried to rationalize it, outgassing jets, image compression, even a dust plume, but the geometry persisted across every angle. Natural objects don't arrange themselves with this level of mathematical discipline. And when the next batch of data arrived, the symmetry held. Quietly, without any announcement, the initial internal memo circulated among a handful of researchers. One line in particular stayed with me. If this is a coincidence, it's the most precise one ever recorded. The more I examined the imagery, the more something else troubled me. The extensions didn't match the spectral characteristics of the central mass. They reflected sunlight far more efficiently, almost like polished metal. That shouldn't be possible for a comet drifting through interstellar space for millions of years. Surface weathering alone would erase any such reflectivity. Yet the readings were consistent, persistent, and resistant to every natural model we tested. Some colleagues speculated about exotic mineral inclusions. Others proposed internal crystalline structures exposed by fragmentation, but none of those theories accounted for the uniform spacing or the smooth plane-like surfaces detected in several frames. One analyst suggested, quietly, not wanting his name attached to the thought, that the object might not be a single monolithic rock, but a hollow shell. Hollow comets do not exist. At this stage, the official explanation remained conservative. Unusual geometry, possible fragmentation, unknown composition. But what concerned me wasn't the public statement. It was the missing data. Several timing logs from ground-based radar observations were abruptly restricted. The files weren't deleted, they were simply gone from the public directories, marked as in review, though no review logs existed. No one explained why. Around the same time, independent observers reported strange electromagnetic interference during the object's closest pass near Mars. The pattern was irregular, brief, and easy to dismiss as equipment noise. Yet it occurred at the exact moment the high-resolution images were being transmitted. The coincidence was noted but not investigated further. Every new dataset forced me to revise my assumptions: the stable spin rate, the anomalously low mass estimate, the precise orientation of the extensions. No single measurement proved anything extraordinary, but together they painted a picture I couldn't ignore. A picture of something that behaved less like a natural wanderer and more like a structure, deliberate, symmetric, and possibly functional. Still, every time I tried to follow that line of thought, I stopped myself. Science does not leap to extraordinary conclusions. It steps cautiously, one verified observation at a time. And yet, even with that caution, one question kept circling back. How many anomalies can accumulate before they stop being anomalies? As more data arrived, the object continued its silent approach toward the sun, its behavior calm, deliberate, and inexplicably stable. Nothing about it resembled a dying comet shedding debris. If anything, it looked as if it were preparing for something. Whether that preparation was natural or artificial, I couldn't yet say. All I knew was that the deeper I went into the numbers, the more the mystery grew, and the moment that pushed everything over the edge was still ahead of me. What happened next changed the entire investigation. I had thought the symmetry alone was the turning point, but the real shift happened when the higher resolution frames arrived from the Mars Reconnaissance Orbiter. The first part of the puzzle had shown structure, the second revealed purpose. Even now I remember the moment clearly, the image sharpening, the contrast stabilizing, and the three extensions of 3I Atlas emerging not as irregular formations, but as aligned components. At first glance, the surfaces looked too clean. The planes were uninterrupted, smooth beyond anything produced by cosmic erosion. When I viewed the enhanced infrared overlays, the reflectivity patterns reinforced the impression. These structures behaved less like rock and more like engineered panels. Natural minerals scatter light irregularly, especially after millions of years of interstellar radiation. These reflections were coherent, almost metallic, and far too stable across the sequence to be dismissed as artifacts. Colleagues tried fitting them into natural models. Several proposed highly ordered crystalline deposits. Others attempted to simulate erosion patterns under extreme temperature cycles. But each model failed in the same place, the geometry. No natural process forms three identical protrusions at exact angular separations. Even if chance could shape one, it would not sculpt all three to match with such precision. One internal report described it as geometrically implausible under known astrophysical conditions, which, in our field, is a restrained way of saying impossible. What troubled me more was the mass discrepancy. Using the updated rotational and acceleration data, the mass estimate dropped even further. Given the object's size, several kilometers across, the readings suggested it was astonishingly light. Too light. The only physically consistent solution was internal hollowness. That conclusion didn't appear in the public summary, but it circulated quietly among analysts. A hollow interstellar object with structured extensions raised questions none of us wanted to articulate. Still, the official line remained cautious. Symmetry could be misleading, reflective areas could be transient, the mass estimate might be off. But beneath those disclaimers lay a growing sense of unease. We were accumulating too many weak anomalies, each one inconclusive on its own, yet collectively pushing us toward a boundary we were trained not to cross. Then came the temperature readings, and with them, the moment the entire narrative shifted. As 3I Atlas moved closer to the Sun, its surface temperature should have risen predictably. Instead, it stabilized at a value far below the expected thermal profile. The curve flattened with unnatural precision, as if regulated. I checked the calibration, reran the model, even compared instrument logs from different observatories. There was no error. Something was maintaining the object's temperature deliberately. Several researchers suggested deeply buried volatiles, endothermic reactions, or layered insulating materials. But none of these mechanisms could account for the fine, perfectly maintained equilibrium, especially across a structure with exposed reflective surfaces. Regulation implied a system, not a mineral. Around this time, data logs from one ground-based radar facility disappeared from the shared archive. The timing coincided with the anomalous thermal measurements, but no one provided an explanation. Missing data isn't unusual in large observatories, yet the absence of metadata, revision history, and error reports raised concerns. When I asked about the missing files, the reply was brief. Under review. No review ID, no follow-up. What came next blurred the line between observation and implication even further. A faint electromagnetic fluctuation occurred during one of the closest passes, a short, broadband disturbance detected simultaneously by two unrelated instruments. The amplitude was small, barely above noise, but the timing was exact, occurring at the moment when the object rotated its extensions into a particular alignment. Most dismissed it as interference, yet the coincidence lingered. By now, the idea of a purely natural explanation felt strained. The hollow interior, the stabilized temperature, the symmetry, the reflectivity. Each piece suggested design, but without a smoking gun, all we had were patterns. Science requires caution, and speculation is always kept at arm's length. Even so, the thought kept resurfacing. If these features weren't natural, then they were intentional. I kept telling myself that nature can produce illusions of order. But the deeper I analyzed the datasets, the more it felt like the object wasn't simply drifting. Its rotation was too stable, its brightness curve too controlled, and its geometry too deliberate. Yet without definitive evidence, every interpretation had to remain a hypothesis. All of this converged as the object approached its perihelion. Its behavior should have become increasingly chaotic, jets of sublimating ice, shedding of debris, a rising coma. Instead, the brightness remained eerily constant. No outgassing, no disruption, no fragmentation. On the contrary, the symmetry held, as if the structure were preparing for something. Even now I remember the silence in the control rooms as the object neared its closest approach to the sun. We weren't just watching for scientific curiosity anymore. We were waiting for confirmation, one way or another. What happened at perihelion defied every expectation we had left. I had expected 3I Atlas to fragment at perihelion, or at least brighten as any natural comet would. Instead, the moment it entered the sun's corona, it did the opposite. It stabilized. Looking back, that was the true turning point, the moment when the last natural explanation slipped away. The temperature readings held at the same precise equilibrium as before, despite the brutal heat. No outgassing, no coma, no thermal spike. Just a silent, unchanged structure passing through conditions that should have torn it apart. In the first seconds after the perihelion crossing, the telemetry looked almost artificial in its perfection. The object behaved not like a tumbling rock, but like a system maintaining its own internal state. What followed was even more revealing. The three extensions, the geometric structures we had been analyzing for weeks, began to shift. Slowly, with a precision that reminded me more of mechanical unfolding than any natural rotational drift, the arms repositioned. Their alignment shifted toward the sun, forming a new configuration that was too deliberate to misinterpret. Natural objects do not reorient themselves with millimeter accuracy. As this happened, the smaller fragments first identified near Mars began to drift inward. Observers initially thought they were debris caught in solar wind turbulence, but their trajectories contradicted that. Instead of scattering, they moved together. Instead of tumbling, they stabilized. They formed a spiral, a logarithmic pattern so clean it could have been drawn on paper. No natural process produces a self-organizing swarm with coordinated vectors. The pings began shortly after. Not a communication, at least not in the way we understand communication, but a diagnostic pattern, multiple frequencies, broad spectrum, repeating at specific intervals. They resembled the calibration pulses of an instrument, a system checking itself, indexing the environment, scanning. The coincidence between the swarm's formation and the onset of the pulses could not be dismissed. Several analysts attempted to classify the signal as a solar interaction, a harmonic of the corona. But the modulation sequences were too structured. Each pulse had a timing offset mapped to the precise position of one fragment in the swarm. It was a distributed system, dozens of points acting as one, and each time the pulse echoed back to the central body, the spectral signature of the main structure shifted. As if the object was collecting the data, integrating it, updating. One of the more senior researchers described it quietly as tomography on a solar system scale. It was an unsettling thought. A machine, if that's what it was, actively mapping everything. Planets, asteroids, magnetic fields, with a method far beyond our own capabilities. I kept thinking about the hollow interior. If 3I Atlas truly was mostly empty, the purpose of that emptiness became a pressing question. Was it a chamber? A sensor lattice? A processing cavity? Or something we hadn't even conceptualized? The internal resonance readings, small rhythmic oscillations detected during the pulses, hinted at a structure responsive to the swarm's activity. The amplitude was subtle, but the pattern was impossible to ignore. At this point, another anomaly surfaced, one that never made it into any public report. As the swarm spread, several instruments recorded a faint energy absorption dip across multiple wavelengths, centered on a region just above Earth's orbital plane. It was too small to classify, too inconsistent to model, and yet it repeated twice. Analysts suggested interference, but the timing again matched the swarm's scanning pattern. It was as though something in our region of space had momentarily absorbed or redirected the incoming pulses. I couldn't shake the thought that the object was looking for something specific. And then, without warning, the pulses stopped. The swarm froze in place. Every fragment, every reflective point, became motionless relative to the central body. The silence that followed was unnerving. Data streams that had been active for days went flat. Instruments picked up only the ambient noise of the solar environment. For a moment we thought the system had powered down, but the brightness of the main structure began to shift. Not chaotically, not thermally, but rhythmically, like a controlled redistribution of internal energy. Spectral analysis showed a new signature emerging. Not sunlight, not reflection. An emission. A narrowband release of structured radiation that didn't match any known chemical or nuclear process. If the previous pulses had been diagnostics, this was something else. An activation. The geometry of the object reinforced this notion. The three extensions locked into a rigid triangular formation, forming what looked like a stabilized array. The triangular plates along the surface began to vibrate, each one resonating at a matching harmonic. The vibrations converged into a unified frequency, a frequency that propagated outward, detectable even through solar noise. And then the impossible happened. A focused beam emerged from the central axis of the object. A clean, coherent stream of energy, narrow enough to appear almost surgical, aimed not at the sun, not at the swarm, but outward, away from the inner system, toward deep space. I traced the initial vector. The beam pointed toward a region near Epsilon Eridani. A young star. A nearby system. Not random. Not accidental. What 3i Atlas transmitted remains beyond our decoding. The beam was complex, layered with mathematical structures far beyond simple patterns. It carried information, of that much we were certain. But whether it was a message, a report, or a signal waiting for an answer, no one could yet determine. And as the beam intensified, one question overshadowed all others. If this object was reporting something, then who, or what, was supposed to receive it? I had thought the transmission itself was the climax, the moment that defined everything. But the real shift came afterward, in the strange silence that followed. The beam continued steadily, unwavering, aimed at Epsilon Eridani, yet the object itself grew quieter. No more pulses, no more swarm movements, just a steady, deliberate broadcast into the void. From the outside, it looked like completion. But the data we gathered suggested something more complicated. The first sign came from the swarm. Those dozens of smaller fragments, previously acting like parts of a distributed sensor array, began to drift again. But not outward. They were returning. Not chaotically, not under solar pressure, but along carefully controlled paths. Each fragment traced a curved trajectory toward the central object, maintaining spacing with uncanny accuracy. It was as if they were docking. I watched the infrared feed as the swarm approached the core. The thermal signatures shifted subtly, showing changes in surface alignment. Some fragments were absorbed directly into the structure. Others attached themselves along the extensions, reinforcing their geometry. Step by step, the object's silhouette grew sharper, more defined, purposeful. It did not look like a comet anymore. It looked like a machine entering the second phase of a long-delayed operation. Then came the mass anomaly. As the swarm reintegrated, the mass readings changed, not increasing, as one would expect, but redistributing. The gravitational profile became smoother, more balanced, as though the object were adjusting its internal structure to restore equilibrium. One analyst described it as structural reconfiguration, though no one wanted to use the word repair. Still, the idea lingered. Around this time, we noticed another irregularity, a faint, repeating fluctuation in the solar wind near the object. It was small, a pattern buried in the noise, but each fluctuation coincided with a microshift in the object's reflectivity. The effect looked like controlled electromagnetic shaping, subtle but deliberate. Natural bodies do not regulate their interaction with the solar wind. And yet, that seemed to be exactly what was happening. The beam continued without interruption, as if the object needed no additional energy, but the internal thermal gradient told a different story. The temperature inside the hollow core had begun to rise, not because of solar heating, but because of something happening internally, a process, a mechanism, a reactivation. When the first radio telescopes began triangulating the beam's modulation pattern, a secondary discovery emerged. Buried within the main transmission was a faint cyclical shift, an encoded correction adjusting for motion, drift, and cosmic noise. It was actively compensating for the 12 light-year distance to Epsilon Eridani. The beam wasn't just being sent, it was being refined, tuned, optimized in real time. That meant the object wasn't simply broadcasting, it was expecting the message to matter. But what unsettled me even more were the side echoes, weak, low-frequency anomalies appearing in a region nowhere near the beam's target. They originated from the outer asteroid belt, trailing behind the object's earlier path. At first we assumed interference, but the timing patterns matched the swarm's earlier scanning cycles. Something out there was responding, faintly, quietly, but deliberately. When I raised the possibility in a meeting, the room fell silent. If something remained behind, a relay, a sensor, or a dormant subsystem, then 3i Atlas had not fully departed our vicinity. It had left pieces of itself where it had earlier mapped and scanned, pieces with unknown function. Shortly after, another anomaly appeared, a faint tone detected by a deep space radar array in the southern hemisphere, only 3 seconds long. A rising frequency sweep, nearly identical to the system diagnostic ping used by the swarm weeks earlier. But there was no swarm now, no active pulse, only silence. The tone came from the belt, not from the main object. Analysts classified it as unconfirmed, but the metadata didn't lie. The frequency pattern matched a signature we had seen before, and the recurrence, twice in 12 hours, made coincidence unlikely. Still, no official report acknowledged it. The closer we looked, the more patterns emerged. Tiny variations in the beam's side lobes, gravimetric ripples near dormant fragments, faint periodic reflections far from the main trajectory. Nothing strong enough to announce itself, but nothing so random as to be dismissed. It felt increasingly as though 3i Atlas was not acting alone. By the time the object moved past perihelion and began its long outbound arc, the world's attention had already begun to shift. The official narrative spoke of a geometrically unusual interstellar body that had behaved inconsistently with known comet dynamics. A carefully neutral phrasing. No mention of the beam, no mention of the swarm, and certainly no mention of the echoes. But those of us who had watched from the beginning could not ignore the implications. The probe, if that is what it was, had gathered data. It had transmitted its findings. It had reconfigured itself. And then it had left behind something that remained active. Even now, monitoring stations report brief, irregular fluctuations in the same bands the swarm once used. Nothing sustained, nothing decoded, just faint reminders that something is still out there, something patient, something waiting. And if the final stage of 3i Atlas's mission was not departure but initiation, then whatever comes next may not arrive from distant stars. It may already be here. I had assumed the echoes from the asteroid belt were the last traces of 3i Atlas, a fading residue of activity from a machine that had already completed its work. But the deeper we monitored, the more I realized that the object's departure was not an ending. It was a threshold, and the behavior of the remaining fragments suggested a phase of the mission we had never anticipated. The reminders from the belt continued irregularly, faint tones, rising sweeps, low-frequency pulses with the same structural signature as the earlier diagnostic pings. Each event was small enough to be dismissed individually, but together they formed a pattern, a slow, deliberate rhythm, as if something dormant was cycling through a sequence of internal checks. At first, the analysts argued it was simply residual motion or thermal settling inside metallic debris. But the timing intervals aligned too precisely with the object's earlier scan cycles. A natural remnant drifts into randomness. These signals did not drift, they repeated. I kept thinking about the swarm's behavior before perihelion, the synchronized spiral, the coordinated mapping, the clean geometry. None of that implied passive fragments. These were components of a system, and now that system was scattered throughout the outer belt, silent yet responsive when probed by the environment. The first major anomaly after the departure came from a gravimetric sensor in Chile. A faint tug, tiny but measurable, originating from a region with no catalogued objects of sufficient mass. The displacement lasted only minutes, but cross-referencing the time code showed something startling. The disturbance aligned exactly with one of the faint belt echoes picked up earlier that night. The implication was clear. Something moved. No official interpretation was offered. Then came the optical detection. A high-sensitivity wide-field array captured a brief glint, a reflection inconsistent with tumbling debris. The reflection held for 2 full seconds, stable, controlled, before fading. When enhanced, the signature matched the reflective surfaces of the swarm components seen near Mars. It was the first direct confirmation that at least one fragment had not only survived, but retained its engineered surface properties. As the days passed, similar anomalies emerged. A pair of near-synchronous electromagnetic dips, separated by hundreds of kilometers. A sudden brief alignment of multiple reflective points before dispersal. Weak thermal signatures that appeared for seconds at a time, then vanished. Each pattern small, subtle, incomplete, yet consistent with an underlying system that had not fully shut down. During one late-night review, a colleague posed a question none of us wanted to voice. What if these fragments aren't waiting for something to return? What if they're waiting for something here? It was an unsettling possibility. The swarm had mapped our system in extraordinary detail. It had scanned Earth with the highest intensity. If the probe's purpose was simply observation, it had already collected everything it needed. So what role did the fragments now serve? One hypothesis suggested they were passive sentinels, long-term monitoring components left behind to track changes in the system. Another proposed that they were a redundancy measure, a distributed memory array preserving data in case the main probe never reached its destination. Both ideas sounded plausible, yet incomplete. The more disturbing theory came from analyzing the timing of the last transmission. The beam toward Epsilon Eridani had been steady for days, but embedded within its structure were slight amplitude fluctuations that, when isolated, mapped onto the positions of the remaining swarm fragments. It was as though the beam was acknowledging them, or instructing them. If that was true, then the fragments were not abandoned. They were part of the message. Around this time, a new anomaly surfaced, one that still troubles me. Several ionospheric monitoring stations detected faint, repeating modulations, too weak to classify as a signal, yet too structured to be noise. The pattern resembled the early ping sequence used by 3i Atlas when it first began scanning the inner planets. But there was a crucial difference. The frequency decay matched atmospheric absorption characteristics on Earth. The source wasn't deep space. It was somewhere between the upper atmosphere and low orbit. No orbiting spacecraft reported anomalies. No debris clouds were detected, but the pattern persisted over 3 nights before disappearing. If it was an echo, it was the first one we had detected from so close to home. The official narrative remained unchanged. The probe had passed through, behaved unusually, and left. The fragments were dismissed as inert debris, and public agencies closed their active monitoring windows. But those still following the classified data stream saw something else. The gradual emergence of a distributed pattern spanning thousands of kilometers, forming and reforming in faint, silent rhythms. Not enough to reveal intent, yet enough to signal presence. Whatever 3i Atlas achieved at perihelion was not a simple transmission. It was a trigger, a beginning, not a departure. And as the last confirmed detection faded into the background noise of the belt, one quiet conclusion settled over everyone who had been watching closely. The probe had not left us behind. It had left something with us, and whatever that something is, it hasn't finished its work.